All right, so we first want to distribute. We want to multiply 3 times y is 3y. 3 times 2 is plus 6 equals 30. Then we look at the side with the variable y. We want to undo addition or subtraction first. So if it's plus 6, I want to do the inverse and subtract 6 from both sides. 6 minus 6 is 0 and cancels out. So we bring down the 3y. 30 minus 6 is 24.
That'd be 8.
Then we look up the variable 3 times y. We want to get rid of that 3, so we need to do the inverse, divide by 3. X equals 8 is our one solution. Put a box around that. Questions?
If we put y equals 8, that's what they're doing, right?
Oh, I'm so sorry. I should have put that. You know, I always, no, say that, please. Oh, you guys, I make mistakes all the time. Correct me. I think a lot of us do that. You know, we're so used to x. I always put x. So yes, put y equals 8. Sorry. And then check your solution. So remember, you're going to have to do this on your CYU today and on your quiz. So we just want to go back to that original equation, and then instead of y, we're going to put 8 in parentheses. So I'll still put the 3 parentheses, and then where I see the y, I want to put another set of parentheses, 8. So you're going to have double parentheses there. Plus 2 parentheses equals 30. So I wrote everything the same. I just put parentheses 8 instead of y. Then we just solve regular PEMDAS, so we're not doing inverse operations. So we look inside the parentheses first, P for parentheses. 8 plus 2 is 10. So I'm going to put 3 times 10 equals 30. So like this 30 on the right side doesn't change because there's no operations over there. So that should not change. You shouldn't be doing things to both sides. Then we multiply 3 times 10 is 30. 30 equals 30. Checks out. So if it's a true statement, it means we're correct. 30 is equal to 30. So our end result is y equals 8. If you have different color pens and you want to color code, I'm going to do a different color for the center just because it helps me visually separate the two, but you can do it in pencil too. All right, next one, rewrite the given equation. 5 times 2 plus c equals 45 plus 5c. All right, distribution. We need to multiply this. 5 times 2 is 10. 5 times c plus 5c equals 45 plus 5c. So we have a variable term on both sides. So that's what I always start with. I suggest always doing getting rid of the smaller variable. They're both the same, 5c, so we're doing the same thing. So if it's plus 5c, subtract 5c from both sides, and they both cancel out. So then we have 10 equals 45. Is that a true statement? No. So then put the line through the equal sign that shows 10 is not equal to 45. We can't go any further. We have no solution, so we can't check our answer. So you can put none, or I always put NA, non-applicable, whatever you want to put there. You can just cross it off, but we can't check our solution.
Well, wouldn't C equal 7?
No, because we canceled out both C's. If we do minus 5C to both sides, those are 0.
Well, why wouldn't you subtract 10 and 45?
Okay, so here, let me do that on a sticky note. Let's try that route. You could do that, so let's see what that would do. So we would, if we were at 10 plus 5c equals 45 plus 5c, and then you say subtract 10 first?
Yeah.
Okay, so let's subtract 10. All right, so then we have, that cancels out, we have 5c equals 35 plus 5c. And then we have to get all of our variable terms on the same side. So we would have to subtract 5c again. And then 5c minus 5c, it cancels out, so we have 0. Those cancel out, then we have 35. So if you did it that way, it still is not a true statement, so it's still no solution. Because like, go back to this, if we have 5 times a number on one side, and then we have 5 times that same number plus 35 on the other side, it'll never be the same number on both sides. To have a solution, it has to be a true statement. So then our end result was 10 does not equal 45. So if you get that as your end result, it's not a true statement, that means no solution. All right, and then the last column is infinitely many solutions. We have 2 times a minus 2 equals 2a minus 4. Again, we need to distribute. 2 times a is 2a. 2 times negative 2 is minus 4. Equals 2a minus 4. And then again, there's more than one way to do it. You could start with the 4s. I always start with the variable term just to keep it consistent every time. So that's the way I'm going to model it, but you guys could just start with the 4s. But I again like to get rid of the smaller variable term. They're both 2a and they're both positive, so I'm going to subtract 2a from both sides. Those cancel out. We have negative 4 equals negative 4. So remember, if it's the exact same term on both sides, it means it's infinitely many. And then it means any number would work with this equation. But to check our solution, we'll at least just check negative 4. So 2 parentheses, and then remember, put a parentheses again where we're substituting. Minus 2 equals 2 parentheses, negative 4 minus 4. And then do parentheses first on the left side. So we have negative 4 minus 2, which is negative 6. And then I can start simplifying the right side. I can multiply first. 2 times negative 4 is negative 8, and then minus 4. And then 2 times negative 6 is negative 12. Negative 8 minus 4 is negative 12. True statement. And you could test out a couple other numbers to check to make sure it was infinitely many. So our end result was negative 4 equals negative 4. All right, now we're just going to use those same equations to see, again, let's talk about what the coefficients are and what the constants are on both sides. So we're going to go back to where we simplified each side. So we distributed and combined like terms. So here we had 3y plus 6 equals 30. So we're just using that same simplified equation. So before you can really tell how many solutions, you have to distribute and combine like terms. Okay, so for this one, what is the coefficient? 3, just the 3. Remember, y is the variable, so the coefficient, so if you want to highlight it, maybe in the same color you highlighted coefficient on the front. And then I'm going to highlight green for my constants like I did in the front. What is the constant on the left side of the equal sign? 6. And what's the constant on the right side? 30. So what can you say about the coefficients of the terms with x or with y in the equation? So does one solution have the same or different coefficients? Different. Because over here it's just 30. That means technically we have a coefficient of 0 on the right side, and this one has a coefficient of 3. So if we only have 3y on the left side, it means there's no coefficient on the right. So there are 3 and 0 different coefficients. So you want to remember that one solution always has different coefficients. And then the constants you told me were 6 and 30. So what can we say about those? Different constants. But we did discuss in the packet, when will they be the same constant? When x equals 0. So let's just put same when x equals 0. Or again, whatever the variable is, but usually we have x. All right, and then going to the no solutions, after we distributed, we had 10 plus 5c equals 45 plus 5c. What is the constant on the, actually, sorry, I'll start with the coefficient. What's the coefficient on the left side? 5. What's the coefficient on the right side? 5, so they're both what? The same, so we can say 5 and 5, same coefficients. What's the constant on the left side? And what's the constant on the right? 45, so those are different. 10 and 45 different constants. And then the last one, once we distributed, we had 2a minus 4 equals 2a minus 4. What are the coefficients on both sides? 2. So they're the exact same on both sides, bless you. So 2 and 2, same coefficients. And what are the constants on both sides? -4 also. So everything's the same with it's infinitely many. But again, remember, you have to get rid of parentheses and you have to combine like terms before you can see that. All right, so these are the patterns, and then when you're ready, I'm going to freeze it, but go ahead and glue it in once you're ready. Again, I'm on page 14. You don't have to have the same exact page numbers, so if yours is a little off, that's okay. And then we always have to put a heading and write it in our table of contents, so I'll show you my heading in a moment. Bless you. Today is what, the 23rd, right? 24th? Did I fix? Okay, I wrote on the board. 124.